And our last test is the oxidase test. And this is our catalase test for gram-negative organisms. This is going to be used to tell apart members of our Enterobacter ace family from the other large family of gram-negatives that cause problems in humans, the pseudomonads. So pseudomonads are the only ones that are going to produce this enzyme oxidase, and this is the same thing for these guys. This is what they're going to use to break down those toxic byproducts of oxygen, cytochrome C. Cytochrome C oxidase is what this Pseudomonas organism is going to use to break down their toxic byproducts of oxygen. So anyway, scientists have figured out that this little compound here, TMPD, can be used to trick cytochrome C. You can detect the presence of cytochrome C by turning it purple. So the cytochrome C will accidentally donate some electrons to this chemical instead of getting rid of them like it should be doing in the bacteria. So when cytochrome C comes in contact with this chemical, this is the oxidase test reagent. You don't need to know that. That is totally fine. It turns purple. So cytochrome C will donate some electrons to this instead of donating them to the electron transport chain in the bacteria like it's supposed to, or excuse me, serving as the terminal electron transport receiver as it should. Well, anyway, long way to say this. You have two little slides. You can do slides that have this TMPD embedded on it. You can do a piece of paper with a little drop of TMPD on it, or a cotton swab that you put a little drop of TMPD on it. It's also called oxidase reagent. And then you take a little swab of your bacteria and you rub them on the little slide, or you rub them on the paper, and then you can rub the cotton swab on the bacteria as well and collect some. You let it sit for about 15 to 20 seconds, and then that TMPD will instantaneously turn purple if the organism is a Pseudomonas species. That's an organism that's able to produce this enzyme cytochrome C. So this organism is oxidase positive. These organisms down here that don't change color, or you can see here they stay the same, they are oxidase negative. They cannot produce the enzyme cytochrome C oxidase. They cannot do it. So this is how you tell apart the pseudomonads from the Enterobacter ace species. So you get a patient that has a gram-negative infection. You see that underneath the microscope. You grow it on a petri dish, and this is the first test you're going to do, just like a catalase test, to tell apart your gram-negative caucuses. This is the first test you're going to do to tell apart your gram-negative rods. Is it an Enterobacter ace species or a pseudomonad species? If it's a pseudomonad species, you're done. You know what to do. You can treat that. If it's an Enterobacter ace species, you have to do some more tests to figure out which one it is. So this is how you tell apart the two different broad families of our gram-negatives. This is essentially the gram-negative version of a catalase test to break apart the staph and the streps. This breaks apart our pseudomonads from our Enterobacter ace species. And you can see a little video here if you would like of someone talking through this as well again. So this is the two big tests here that are used to differentiate the two broad groups of our gram-negatives and our gram-positive bacteria. So if you have any questions over this stuff, guys, please feel free to email me. If not, have a good rest of the day.